Okay. Once again, welcome to the In the previous video, we discussed about the system of units. Now, in this lecture, we will study about the dimensional analysis. So here, first we have to know about what is the meaning of dimensional analysis. So here, dimensional analysis is nothing but representation of the physical quantities in the powers of fundamental physical quantities. Generally, the fundamental physical quantities are nothing but mass, length, time. These are the maximum fundamental physical quantities we will use. Extra we will take another four that is represented in a SI system, that is electrical current, temperature, luminous intensity and amount of substance. Okay, so here first we have to learn about what is the dimensions of a physical quantity. The dimensions of physical quantity are the powers of fundamental physical quantities are raised to represent that quantity. Here, for example, I am going to consider the density. Density is a physical quantity. I am going to represent that physical quantity in terms of the fundamental physical quantities. So here density is nothing but mass by volume, and density is equal to mass by volume. Volume is nothing but length into breadth into height. So here the dimensional formula for the density is written as, I am using mass one time here. So that is mass one time m to the power 1. And I am going to consider the length, breadth and height. All are representing the length. So I am using length 3 times. Mass used one time and length is used 3 times. Therefore, the dimensions formula for the density taken as m to the power 1, L to the power minus 3. I am not using any time here. So that is t power 0. Whenever we are going to take the dimension of density can be taken in the density dimensions, we are using the density are 1 in the mass. Dimensions of density are 1 in mass and length can be used 3. 3 in the length and time we are not using 0 in the time. Okay? So meaning of that one, dimensions of physical quantity are nothing but how many times we are using that fundamental quantities. Here mass I used one time, length I am using 3 times and here time does not use it. Okay, and after that dimensional formula. It is the expression which represent physical quantity in terms of the dimensions. Okay, means I am going to take the dimensional formula for velocity. Actually, velocity is nothing but displacement by time. Velocity is nothing but displacement by time. Here mass we are not using, displacement is nothing but length, it is used for one time and time is used for one time. So the dimensions of velocity is nothing but mass not used m to the power 0, length is used one time and in the denominator time is used, it is taken to numerator, it become t to the power minus 1. So this is known as dimensional formula for velocity. Next one is a dimensional equation. Dimensional equation is nothing but we are equating the dimensions to the physical quantity. So here I want to take the dimensional formula for the velocity. Dimensional formula for velocity is nothing but m to the power 0, L to the power 1, t to the power minus 1. Because here velocity is the physical quantity. For velocity I am using length one time in numerator, time is used one time in denominator. So these are the dimensions of velocity. Now we are going to write dimensions of some important physical quantities. See, generally we are using these important physical quantities. So the important physical quantities we are going to take the dimensions. Here first one is velocity. velocity can be taken as dimensions can be considered. So see the dimensions. The dimensions of physical quantity is, now first one is velocity. So velocity can be taken, already we know that velocity is nothing but displacement by time. So from that the dimensions of velocity can be taken as m to the power 0, L to the power 1, T to the power minus 1. And the next one is acceleration. Now here acceleration is nothing but velocity by time. And here we know dimensional formula of velocity. Dimensional formula of velocity is m power 0, L power 1, T power minus 1 divided by time dimensional formula is T. So from that acceleration dimensional formula can be taken as m power 0, L power 1, T power minus 2. With the basic formula, we will derive its dimensional formula. Next one is force. Here, actual formula for force is nothing but mass into acceleration. Now we will take dimensional formula for the force. Dimensional formula of force is nothing but, here mass dimensional formula is m to the power 1, acceleration dimensional formula is L to the power 1, T to the power minus 2. Therefore, force dimensional formula m to the power 1, L to the power 1, T to the power minus 2. Force is the important quantity in the dimensional formulas. With the help of this force, we will derive many dimensional formulas in the coming lessons. So, try to remember the dimensional formula of the force m to the power 1, L to the power 1, T to the power minus 2. And the next one is work or energy. Work and energy both are having the same dimensional formulas. Actual formula for the work can be taken as force into displacement. The dimensional formula means the formula for work is nothing but force into displacement. From that I am going to take the dimensional formula of work. Dimensional formula of work is nothing but force dimensional formula m to the power 1, L to the power 1, T to the power minus 2 into displacement dimensional formula is L. So from that we will take dimensional formula of the work is m to the power 1, L to the power 2, T to the power minus 2. These two, force and work or energy, important. Try to remember these two dimensional formulas because many physical quantities dimensional formulas depend upon these two. And next one is the power. Now here we know power is nothing but work by time or rate of change of energy. So from that the dimensional formula of power can be taken as, it is work dimensional formula m to the power 1, L to the power 2, T to the power minus 2 divided by time dimensional formula is T. So the dimensional formula of power can be taken as m to the power 1, L to the power 2, T to the power minus 3. And sixth one, gravitational constant, universal gravitational constant, very very important. If the question they want to give difficulty, they can give the dimensional formula of gravitational constant. So actually we know that gravitational force is nothing but G into m1 into m2 by r square. This is the basic formula for gravitational force. We want to get what is the dimensional formula of the universal gravitational constant. So from that I am going to write formula for G. Formula for G is nothing but F into r square divided by m1 into m2. Now by using this we are going to write the dimensional formula, that is force dimensional formula m to the power 1, L to the power 1, T to the power minus 2, and length dimensional formula L, but here length square is there, dimensional formula is L square divided by mass dimensional formula is m, there are two masses, so it is m square. So finally dimensional formula of the universal gravitational constant is m to the power 1 divided by m to the power 2. It is m to the power minus 1. Here L to the power 1 and L to the power 2. This is L cube and time is t to the power minus 2. So try to remember and try to understand the procedure to calculate the universal gravitational constant, because directly remembering of the formulas is difficult, but if you understand the procedure, then you can write dimensional formula of any physical quantity. And next one is stress. Here stress is nothing but, here we are going to take the stress. Stress is nothing but force per unit area. So dimensional formula of the stress can be taken as, here force dimensional formula m to the power 1 L to the power 1 t to the power minus 2 divided by area dimensional formula is L square. So we will take it as m to the power 1 L to the power minus 1 t to the power minus 2. So this is the dimensional formula for stress. Similarly, see this pressure. Now pressure is also nothing but force per area. Stress pressure both are having same dimensional formulas. So here dimensional formula of pressure is nothing but force per area. So this is also m to the power 1 L to the power minus 1 t to the power minus 2. And next one is moduli of elasticity. Moduli of elasticity is represented with E, which is the formula for moduli elasticity is stress by strain. And here strain is nothing but change in dimensional by original dimension. Numerator which dimension can be taken, denominator is also same dimension. So strain is dimensionless quantity. Due to that reason, the moduli elasticity is, there are different types of elasticity constants are there. One is Young's modulus and another one is bulk modulus and another one is rigidity modulus. All these moduli of elasticities are having the dimensional formula which is equal to the stress, that is m to the power 1 L to the power minus 1 t to the power minus 2. Okay, na? So these are the dimensional formula for moduli of elasticity. And two more dimensional formulas we will write whenever we are discussing the lessons. In that lessons we will write the all dimensional formulas. Okay, so here I written only which are the dimensional formulas required for us. Is there any question? Any unknown dimensional formula is there, we will derive those dimensional formulas by taking the basic formula. But here these are the certain examples how to get the dimensional formula. And the next one is surface tension. Here surface tension is nothing but force per unit length. The surface tension is nothing but the force per unit length. Now the dimensional formula of surface tension is taken as m to the power 1 L to the power 1 t to the power minus 2. This is first dimensional formula divided by length dimensional formula, that is L to the power 1. So finally the dimensional formula of the surface tension is m to the power 1 L to the power 0 t to the power minus 2. And one more important dimensional formula, coefficient of viscosity. As like gravitational constant, coefficient of viscosity also very important. Here the formula is simple, but deriving the formula is the difficult here. So here we are going to take the viscous force is equal to eta. This is the coefficient of viscosity into area into dV by dx. dV by dx is nothing but velocity gradient. Okay, na? So from that we are going to take formula for coefficient of viscosity, which is force into change in displacement by area into change in the velocity. Now we will write its dimensional formula is force m to the power 1 L to the power 1 t to the power minus 2 into length, change in length is nothing but L, and area dimensional formula is L square, and velocity dimensional formula Lt power minus 1. Now here these can be simplified, L square and L square is cancel. So final dimensional formula of coefficient of viscosity, m to the power 1, L to the power minus 1, T to the power minus 1. So these are the some standard dimensional formulas which we will generally use in the problems. So mainly you remember the dimensional formula of gravitational constant and dimensional formula of the coefficient of viscosity and dimensional formula for the surface tension. Correct? So procedure for calculating dimensional formula is you need to remember their basic formula. Once you know the basic formula, calculation of dimensional formula is very easy. See, first one is velocity. Dimensional formula for velocity is calculating by rate of change of displacement. Next one is acceleration. Acceleration dimensional formula is calculating by using a rate of change of velocity. Next one, force dimensional formula. Force is nothing but mass into acceleration. And next one is work dimensional formula. Work is nothing but force into displacement. And power. Power dimensional formula can be calculating the rate of change of energy or rate of change of work is known as a power. And we know that universal gravitational force, Newton's law. Based on the Newton's law, we find the dimensional formula of gravitational constant. And after that, dimensional formula of the stress. Stress is nothing but force per area. And pressure. Pressure is also known as force per area. And moduli elasticity is stress by strain. And here three moduli of elasticities are there: Young's modulus, bulk modulus, rigidity modulus. And the next one is surface tension. And the final one is coefficient of viscosity. Correct? Coefficient of viscosity is m to the power 1, L to the power minus 1, T to the power minus 1. So these are the dimensional formulas for some standard physical quantities. With the help of those, we can solve the objective questions.